Okay, so this is a recording for 11:06. So a couple things we're going to talk about. The first of which is going to be how do we deal with the max thread problem and the synchronization issues. Obviously, we're going to do some um, synchronization uh, to fix both, actually. And we're going to avoid deadlock in our solution, definitely. However, we're going to demonstrate, hopefully, deadlock. And we're also going to demonstrate, hopefully, how to avoid it. But be aware that it's not obvious, right? So deadlock can often be very difficult to detect. They're very difficult to prevent, those type of things, especially when you have underlying situations. Now, given the code that we're going to work on, we shouldn't have that problem, but we could. All right, so very first thing I want to talk about is I'm going to go over code again. Now, bad news first. What I've actually done here is I grabbed the code from last class, right? Where we shared threads, right? We did the input stuff and all those things. And what I'm going to do here is show you where the two errors are. I don't actually remember, so we're going to have to find it. Okay. So this is the one where I withdraw a certain amount, um, $1, 10,000 times, and you can see that the number is going to be almost always wrong. And you're like, wait, why? Um, I'm only creating 5 threads, right? So P9 is the example of, hold on, I want to rename it. Thread sync issues, right? Or how about just race conditions, right? Race condition fail. There we go. And then there was another one, which I think was P8. And this is one's trying to create 300,000 threads. Can't do it. And as a result of that is producing garbage answers. Okay. And we're going to rename this too many threads. Okay. Awesome. As a result of that, we're going to keep this other code nearby. Excuse me. We're going to keep this other code nearby, but we're going to actually get rid of it. So I'm going to go pop open a terminal real quick. And I'm going to make a directory old and copy p dot c to old. Yes. Um, and we're going to look in the old directory real quick. And there we go. So now we can remove p. Yeah, p star should be fine. Yep. Ta-da. Okay. I did that on purpose because we want to talk about a couple things. First of all, we know we're going to have to do race condition first, right? So the very first thing we're going to do is we're going to fix and grab these, and we know we need to synchronize. And so pretty simple, we're going to synchronize, right? I mean, like that, that's what we're going to do. That is the answer to this question. It is not a particularly difficult question, okay? But where are we going to synchronize, right? Can we synchronize the whole withdraw method? We can, we just don't need to, right? We don't. We just need to lock this, the balance being changed and the balance being checked. If we lock just those two things, we'll end up with a better result. So the very first thing we're going to do is we're going to look in some of the old code and look for the threading. Don't see it. Nope, not an A. Hate how confusing this is. I don't know what the hell went wrong in the previous semester. I know, well, I mean, I do know a little bit about what wrong. I just don't want to talk about it. Um, some weird things were happening that semester. So, same thread. Okay. E's got to be E. Yeah. Trying to create the threads. Sorry. I looked at this. Here we are, right? We just want this mutex, right? I'm going to grab a lock and I want to actually put it in here without actually having the code for it. And you're like, wait, what? I'm going to explain in a minute. Very first thing is this needs to be a global variable. And you go, why does it need to be a global variable? Well, here's a caveat. The way I wrote this, as you can see very quickly, I need the withdraw method to be the actual lock. And so I don't want to have to pass it around from method to method to method. Don't wish to do that. So I want the lock to be there. So the very first things I'm going to do is, yep, I'm going to just run it. And you're like, wait, what? I'm just going to check to see if it actually runs. Okay. Very first thing. I'm not going to call it counter lock. I'm just going to call it lock. Yes. Just a lock is fine in this condition. And then don't remember where the lock is, so I have to do this again. There it is. Lock and unlock. Yay. All right. So I'm going to lock it here, and it is lock, right? I'm going to actually have to pass that address of that lock in, and then I'm going to unlock it here. And hopefully you immediately say where there's an unlock, how these things happen to where we have unlocking issues. If I don't remember to unlock here as well, if I just lock up here, we can very easily be in a situation where the lock will never open. Okay. So that is your lock. And we're locking the bare amount. How do I know I'm locking the bare amount? Because I am. Um, I'm locking data, and the only time we change balance is this. It's the only time balance has changed. So, excuse me. Sorry. We fixed it, and then let's run it. And you go, wait a second, it's still wrong. Let's first, before we get excited, let's double check what we're doing. 10,000 times. Yeah. So clearly it's removing. Okay. So just quickly, right? I'm just throwing this in here. I think the calculation is wrong. It doesn't mean I did it wrong. 10,000 times 5 is 5,000, 50,000 coming off of it, right? Right. This is going to be deducted from your thing, right? 50,000. But your balance started off to be this number. So I think I'm almost certain that the should be number is in fact incorrect. Yes, the should be number is definitely incorrect. Um, let's see if that actually resulted in an overwrite. Let's see. I don't know how I got that wrong, but let's fix it. Should be, actually, let me just put it here. Oh, I see. It's just missing a zero here. All right. So now, well, now for sure, we're not. Okay. Now for sure, we're not failing. But I just want to point out a couple things. Race condition fail without it. Let's fix the thread. So clearly I just added a zero here. Bang. And let's see. Yeah. So it does produce a different number. And you go, wait, what? Yeah, it does produce a different number. Every now and again, though, it will produce the right answer. And you're like, wait, what? Yes, every now and again, it's going to produce the right answer, but it only has to run once incorrectly in order for there to be overwrite. Okay. All that just means is the threads were going really rapidly, and then it actually finished that 10,000, 1,000 times fast enough, but it's clearly incorrect. Now, it doesn't matter how many times, now that I have the race condition, doesn't matter how many times we run it, right? I mean, I can run it 50 times and you go, okay, this is okay. So the race condition failed now. Okay. But it did work a couple times. What can I do to make it fail more commonly? Easily. I just add the 100,000, right? And you're like, wait, no way. Can't be that simple. Okay. And then I'm going to go to P1C and I'm going to add the 0 here. And I'm going to add the 0 here. Should actually put that as a variable, a defined variable. All right, let's look at the race condition fail. And this should no longer be infrequent, right? This should be every time we run it, it's going to produce a wrong number. Yes? Nope. We got one correct out of 5. One correct out of 1, 2, 3, 4. Okay. The bigger I make that number, the less likely it is going to be accurate. So here's a case where I did 5 of them and only one of them was accurate. And all that is it's going through that fast enough. Now, if I add another set of zeros, right? We're getting to the point where that's going to be too many, but we're not there yet, right? It's never going to be negative 40,000, okay? And you go, wait, what? Can't be smaller than that. So let's add 2 zeros here. Okay. And it's right every now and once and again, even though it's running 100,000 times inside the thing. However, you can see that it is in fact getting it wrong every now and again, but it should be more frequent. But that was weird. But in any case, no matter how many times, because of these locks, this is never wrong. Okay? Never, ever, ever wrong. It's impossible for it to be wrong because of the locking. So this is our synchronization case. Um, Pretty simple. What do we need to lock? We need to make sure we're locking data. We're going to talk about this in a little bit more detail. But before we go on, we want to solve the too many threads problem. Okay, too many threads, a little bit harder. Okay, not impossible. Okay, so what we're going to do is do, 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 do. Sorry, this is a race condition fail. Um, no, this is too many threads. So this is a fairly simple thread, and it's just creating too many of them. So what can we do to avoid that? Well, we can create a max threads, right? And maybe we only create 1,000 of them, whatever. It does not matter. We need a max number, right? So what we're going to do is we're going to make sure that the max number is not higher than this. Yes? Now, I know for a fact that the number of threads I'm going to create, I now just need to, right? Right? If the number of threads I have is bigger than, let's say, my threads, right? So if my threads, hmm, why is it not like this? That should be fine. See that. Let the compiler tell us. Oh, just doesn't like the fact that it came first. Oh, yes. Those of you that don't see that, that's all I did wrong. It was fine. It just didn't have it had the, what's it called? Okay. So if my threads is less than max threads, we're going to go ahead and create the thread. Um, right? Else, we're gonna wait. And you're like, wait, what? We're gonna wait. All right. Now, good news, bad news. The only way to have a wait is to put this in here. Okay. To come free, right? Because now you've created the max number of threads, so now we can't do anything. Yes? Great. This is a problem, right? Because we have the join separately, right? We can put a join in here. And so if it's going to wait for a thread, we got to go join something. Okay. Um, that is certainly possible. What we can also do is another method. Watch this. We go void. Actually, int. Nope. I'm screwing this up. Give me a second. I'm sorry. I'm close, but I'm not exactly close, right? So what we're going to do is we're going to create an asynchronous method here. Watch this. Okay. So the p threads, when it's finished, right? All it's going to do is call this thread finish model. Yes. And what that's going to do is going to go, right? No, I got this wrong. I'm sorry. I had it right originally. And then you know what? I screwed it up. I'm sorry. I did screw it up again. Takes a p thread finished. Um, right? Um, all right, I'm doing this incorrectly. I need to pause the recording because I'm hitting a brain fart. Yeah, because what I was going to do is have the thread in the thread function when it's finished, call the thread finished. But if it calls the thread finished, what ends up happening is what? It's joining itself. That's not going to make any sense, right? Um, Okay, I remember what we need to do. I'm sorry. Yeah, I apologize. Brain fart. I'm 50 years old. Sometimes this happens. But pretty simple. This is where um, we need synchronization, right? So what I'm going to do is I'm going to have an int here. I'm no longer going to have this be um, a local variable. Instead, I'm going to have it be a what's called variable. And what I'm going to do is I'm going to increase. No, do the opposite. Sorry. Right? And so what's going to happen is it's going to, at the end of this, hmm, it's going to decrement threads, right? We might need that thread ID, so that's why I'm saving that. Okay. So we're going to decrement threads. Okay. So we're going to go while my threads is less than max threads, right? And I'm doing nothing. This is what we call a spin wait. So it's going to wait till we can. And then when it creates it, we're going to go ahead and, sorry, I apologize. Took me a minute to remember what I was doing. Yes. Okay. So let's go through it again. All right. So what's going to happen is Yeah, because I don't want to use a data structure. Um, Because I don't wish to use a data structure, I'm not going to do anything crazy here by adding something to a data structure and then joining it later. I could, but I'm not going to. I would have to pass that on to someone else, and I don't wish to do that. So what I'm going to do is the original plan, where because I can create a pthread T of that size, max threads. I can create one of 300,000 size without any issue. So I'm going to leave it to be that. But what I'm going to do is make sure that my threads number is never bigger than max threads. And if it is bigger than max threads, guess what it's going to do? It's going to sit there in a spin lock. It's going to wait until this guy comes along and decrements. But that's bad because what? What happens if somebody else, if three things decrement? Okay. Well, it can only do this once at a time. So we do need synchronization. Of course, we need a synchronization, but we didn't put it in here. Um, so we need the lock. And did I put it in too many threads? Yes, I put it in too many threads. So we do need the lock. This is somewhat of a contrived case, but it's a very important case. And so now what we're going to do is we're going to do the lock. Now, the locking isn't important here. Only one, this is the main thread. This is the only thing that's going to create threads. So this is fine. We just want to lock. I think it's lock. Um, and I think it's lock. And it's the address of lock, I believe. Yes. And this is unlock. Okay. It's the only time it changes. We should definitely make sure that we're locking. I'm going to grab and copy paste this part down here. Okay. And you're like, wait, what? Okay. Oh, I hate that. All right. Anyway, because what I'm going to do is I'm going to lock in this change to my threads. The only test occurs, the only test occurs through here. And it's not locking, right? It's not locking during this process. It's doing what? It is, so I can get rid of this. I hate that code. Okay. It's not locking. It's just waiting for my threads to be less than max thread. So when this gets to be, when this can locks and unlocks and gets to be more than a certain number, it's going to what's called the waiting is all going to happen at the end, no matter what. Okay. But this should produce, it'll happen, fail slowly or quickly. It'll fail very quickly if I did it wrong. Oops. Sorry. Oh, you suck. Okay. Yeah. No kidding. I didn't put a what you call it in there, so I'm gonna just do it backwards. Okay. And that should do it. This is poorly organized code, but gives you the general idea of what we want to do. Um, Remember, this is going to run 300,000 threads. It's going to reduce the number of threads when I'm finished. And as each one is finished, it's going to start a new one. So 300,000 threads will be created. It just won't ever exist at once. Actually, you know what we should do? Let me go ahead and nope, I can do it in here. Ints counter will 0. And just after pthread, I'm going to go ahead and counter plus plus and then printf. Just to give us an idea that it is in fact working or not working. We almost always wanted to solve deadlock by checking to see if it's making progress. Does that make sense? That is how I'm checking this. Okay. Shouldn't have created 300,000, by the way. 3,000 would have been enough. Did I get the one less than or greater than incorrectly? I sure did. Um, Probably did here. My threads is less than max threads. Yes. So this is backwards. This should be this. Yes, so it's never actually creating a thread. That loop never finishes. And you can see, right, it's still creating threads way past the maximum for the system. Nope, it's dying at the same. It never creates that last one. Okay. So I think I have something weirdly working in here. I've never done it this exact way. So I may have something weird working in here. I'm gonna take a break because I knew I should have taken a break a minute ago. But yeah, I'm gonna take a break real quick and then we'll get back. I apologize. I'm just doing something silly, I'm sure. But I'm sure I'll be right back. All right, thanks.